Continuing with Newton's laws of motions and forces. Question number 4. 2 blocks of mass m kilogram and 2.5 kilogram, here's a m1, here's a 2.5 kilogram, respectively are connected by a light inextensible string. The string runs over a light frictionless pulley, there it is, as shown in the diagram below. The blocks are stationary. The blocks are not moving. Good. So upward, all forces must be balanced. And this is a table. They say, state Newton's third law of motion. We already stated that one here. If you miss a video, you're going to have to go back to this one here because it says state Newton's third law. It's called action reaction. If block A exert a force on object B, B exert an equal force on object A in the opposite direction. All right, so we're not interested in everything. I'm going to read the story here. Okay, we already did say. They say calculate the tension in a string. I'm not interested in that. I'm interested in the information. The rest will be Christmas. The coefficient of static friction. This is static when it's not moving. That's maximum friction between the unknown mass m and the surface of the table is 0.2. All right, so what I'm going to do here, I'm going to do exactly how we've been doing the questions. We know nothing is moving. There's no friction here. So looking at the 2.5 kg, there is a downward force, which is the force of gravity. So F subscript G, which is the weight, is 2.5 times 9.8. Let's do that. 24.5 Newton. There is an upward force as well, which is the tension on the string there. We do not know it. Then we come on the M block. There is a tension towards the right. There it is there. And then there is a downward force and an upward force. The downward force is going to be the force of gravity. So the force of gravity here, the way we calculate it, we say the mass times 9.8. So I'll write it as 9.8 multiplied by the big M, because we do not know the value of it. Don't mind the blue force. I draw it longer so that you can see it. They must be equal. The red one and the blue must be equal. So it's a normal force. So it will be F subscript N for the normal force. So upward must be equal to downward. So the normal force will be 9.8 as well, multiplied by the big M. That will be Newton. There is no force pulling to the left or to the right. So now, since these objects are not moving, you can't say acceleration is upward. Neither can you say acceleration is to the left or it's downwards or is to the right. None of those things applies. At this point, the acceleration it's equals to 0 because they told you they are not moving. So this simply means it doesn't matter. You can say top minus bottom or bottom minus top equals to MA, where A is a 0. Another way to say it is to say top forces, the one that are pointing upwards, must be equals to the one that are pointing downwards. So I'm going to do it like I've been doing it before. Let's take this one here because we know acceleration is 0. I'm going to take top minus bottom. How about bottom minus top? It's still the same, I'm saying. So in this case, for the first block, it will be T minus that 24.5 equals to the M. The mass I know is 2.5. And then times by the acceleration, we already know it's 0. So this side becomes 0. I can transpose that T. I can say, not the T, the value, and write T equals to 24,5. This is what we meant, upward equals to downward. So it happens automatically, even though you didn't know that. Then same thing here, we have to work with the forces. Okay, up and down are exactly the same. Here you've got the tension that's holding on the block. All right, you can see, now let's just go to these guys. They say calculate the minimum value of M, or calculate the value of M that will prevent the blocks from moving. If the blocks were to move, because on the big M, no one is pulling to the left, so nothing will go to the left or upwards. The one that's pulling is this one here. It's pulling downwards. If they were to move, this one will go downwards, and then this one will go to the other side. Now, all right, so that means on this one at the top, if there was friction to prevent it from moving, friction will have to pull on that direction, meaning this force, friction, must be equals to the one that's pulling the tension. So we are going to use tension is the same as friction to keep the block from moving, because friction must cancel that one. They must be 50-50. They must equal one another in opposite direction. So you're pretending this is friction. So in this case, because you cannot say forces on the left minus forces on the right, there isn't. It's just T alone, horizontal. It's just T equals to MA. So which means if we're to work out that one, you are going to write T equals to the big M and then times by the A, so you don't know this one we know it's 0, but tension can't be 0 there because we've got that value, because we're saying what if it moves? If it moves, then the friction must be equals to that tension, because now we're shifting to fan. Fan says to get friction, this is what we have, it's mu multiplied by the normal force. So friction, we know, will be equals to that tension, which is 24,5 equals to the mu, which is given to us as 0.2, 0.2. Normal force, we can see upwards equals to downwards, which is 9,8 times the big M. Right, so we take 9,8, so times by 9,8 multiplied by the big M. So we can do this calculation here. 1,96 times the mass, we divide both sides by 1,96. We divide both sides by 1,96, and then we end up with the value of M. So M, to prevent it, it must be at least 12,5 kg, kilograms. So no need for the tension, because we got it to calculate it. No need for the acceleration, because we got that. So therefore, this question, it is done at this point. All right, now it continues to this statement. Remember what we had? We had calculated that one there as 5 marks. Now they say to us, the block of unknown mass M, it's now replaced with a block of mass 5 kilogram. All right, so now let's go back here. We're now doing the changes. We're like, okay, call this one 5 kilogram. That's what they're saying. All right, it's now 5 kilograms. And then they say the 2,5 kilogram block now accelerates downward. All right, it accelerates downwards. The coefficients of kinetic friction between the 5 kilogram block and the surface of the table, it's now 0.15. It's like repeating this question all over again. So now what we are going to do, we already know we've got that, and then this one is going to go downwards now. So let's have the So there will be an acceleration. The acceleration is no longer 0. So I'm removing that 0, but I'm saying acceleration is downwards in this case. And then the block will now move to the other side, the one on the table. And then now we can put 5 kg here. So let's multiply this by 5 kg. All right, we now have 49, but don't forget, they gave us the coefficients of kinetic friction as 0,15, meaning there's a new guy in town. There is friction here. There is friction here that's going to oppose. So we can calculate the value of the friction, because now the normal force, it's now 49, and I told you to calculate the friction. So there it is, friction. It's going to be mu. Remember, it's a new mu. It's not 0,2, 0,15. So it's going to be 0,15 times by the normal force. In this case, the normal force has changed. It's now 49. So we're going to times that by 49 to get the friction. Okay, then friction, I believe it becomes 7,35 newtons. I'm going to slot it in there. Then I'm going to say friction, it's 7,35 newtons. So I think they're going to ask me acceleration, these guys. Okay, they say calculate the magnitude of the acceleration of the block. Again, I start all over again. Remember, we need to do for this one here. Now remember, now the acceleration is no longer 0. We do the net force. So now the winning force is the downward. So 24,5 minus the t. Down minus up. So it's going to be 24,5 minus the tension equals to the mass, which is 2,5. All right, it's going to be 2,5 times by acceleration. It's no longer 0 acceleration. I'm stressing that one. All right, then the next thing, we're going to this block, tension right minus left forces, which means T minus 7.35. So we are going to have tension minus 7,35 equals to M, which was given as 5, then times by the acceleration. Then, according to the mathematicians, they would call this one as equation 1. And they will love to call the yellow one equation number 2. Then let's use one of them. I'm going to use the yellow one. From the yellow one, I'll just say T equals to 7,35 plus 5A. All right, so all of that needs to go and be substituted there. Put them in a bracket because the negative will affect the 7.35 and the 5A. I'm going to substitute it there, already changed the sign. So it's 24.5 and then minus 7,35 minus the 5A. All of that equals to 2,5A. So I'm going to take this one, we'll go over there. It's going to be 7.5. And then we calculate these values. Let's do so. All right, and then I said this one should be 7.5 because you're taking the 5 to go over there. Then we divide both sides by 7.5. Divide by 7.5. And then we are going to get the acceleration. So the acceleration would be 2,29 meters per second squared. For the 5 kg, it will be to the right. For the 2.5 kg, it will be downwards. All right, so now let's see what else, if there's anything here. All right, and then that's it. Okay. In this question, we focus on 4.2. It says a small hypothetical planet X. There's a planet that has a mass of 6.5 multiplied by 10 to the exponent of 20 kilogram. That is the mass of a planet, and a radius of 550 kilometers. We should change that to meters. They say calculate the gravitational force or the weight that planet X exerts on a 90 kilogram rock on this planet surface. Let's pretend there is a planet and there is a rock here. So the distance from the center to that man, in this case it will be r. So the distance will be r from their center. All right, according to Newton's fourth law, we know that the force of gravity can also be given as big G multiplied by the big M multiplied by the small m all over, I love to say the d squared instead of r because people think it is the radius. Now we need to remember what big G is. I believe it's 6.67 for most people, multiplied by 10. I would want to believe to the negative 27. Check me out. Minus 11, not 27. Now we can now use the formula. We can now write the force of gravity. It's going to be the mass of the planet, which was that one there, which is going to be 6.5 multiplied by 10 to the exponent of 20 multiplied by the mass of the guy, which is 90 kilogram, times, I'm putting the constant at the end, which is 6.67 multiplied by 10 to the negative 11, and we divide by the distance from the center. In this case will be that radius. So because it's in kilometers, I need to write it 550 and add 3 extra zeros. 1, 2, 3. Close the bracket, all squared. It's in meters. And we get the answer. Rounding off to 2, I've got 12.90. It will be Newton. It's always the force of attraction. Thank you.